Untug that. Take this off. Right there. Spit. Small whirlpool, but let's try to make it bigger. Pull it up a little bit. You can see there's a whirlpool. It's just a very small whirlpool. Yep. Alright, so there's water, as you can see, coming out the bottom. See, I can point it. Coming out the bottom. There's a nail, and I pulled the nail out. I used the butter knife to pull it out. So you see there's water coming out from there into this container. So it's draining out of here. There's water in here. So pick that up. See, water coming out of here. It's going into this half of the bottle. And this half of the bottle is draining out into the big container. As you can see, that's where it's going. And the idea is, let me try to spin it up some more, is to create a whirlpool. See how it's spinning. There's a whirlpool in the middle. Now, lift it up a little bit to try to get, see if I can create a stronger whirlpool. Let me bring out water. You see, the water that was in this one went into this container, and then the water that's going in here is going into this container. So it's slowly draining out that way. The water that's in this container, that was in this funnel, you want to call it funnel, went in here. So instead of this overflowing, it's going into there. So the water has to go somewhere. So the water from here has to go somewhere, which is into this container, right into this bottom one. But then the water here has to go somewhere. If not, it'll just overflow. So we need the water to go somewhere. All right. That's going to obviously eventually overflow because the water that was in this container and the water that's in this container is not going to fill up this. So it's already getting close to the top. So at some point, this is going to do an equilibrium, as it were. As you saw for a little while, let's put that in there. For a little while, there was a whirlpool that was created here. So so what I figured out from this experiment, I was testing out how to create a whirlpool. The hole in which the water is draining, the size does matter. Then there's the fact that the water that's coming out has to come in contact with water, because when the water comes out, it does come out twisted. Like it does twist. It does like a double helix like effect. But then you don't get the whirlpool. So then it's like, okay, well, I noticed when I dipped this funnel right into a body of water, a container that had water already in it, then it started doing the whirlpool effect. And it's like, so that's how you get the whirlpool effect. So as you can see, that's why I made this whole contraption. Of course, I had to make it of plastic so you can see the components and see it in effect. As you can see, it's literally just plastic food container. This was a plastic Coca-Cola bottle that I cut in half. So here's the top half of the bottle. See, so it does connect. This was the top half. You just put the top half in there and act like a funnel. And then as you can see, I made a hole in it, which is almost the same size as the little circle inside that little recycling logo. So you can see synergy. As you can see, this got to the top. So it's going to eventually overflow. So I gotta start recording and empty this out. I just want to show that it does create a whirlpool. So this is most of the physics behind the effect of the whirlpool. So of course, if I can keep filling the top with water, keep having this drain out into the source, into a container like this, right? And then take the water from here and put it back there, and then it just has like an infinite loop, basically. That's the idea. And because of the way this is designed, it should keep creating the little whirlpool effect. I want it to be a stronger effect, but I'm still learning. I don't know all the measurements, the full ratio. That's what it's ratio. I don't know all the ratios that I need in order to get the most out of this. Obviously, I'm just winging it. I'm just experimenting. But at least now I just showed that there is a way to create a whirlpool. As you can see, it was spinning, right? Water spinning, and as you see, there's no batteries. Let me show you. There's no batteries anywhere. Right? It's literally just a cap with a hole in it. Right? Literally a cap with a hole in it. There's no water, there's no batteries or motors anywhere. But you saw. Let me stand up right quick. It's just a table. Dinner table. All I got is that butter knife. Right? A cup of water that I poured into here, which came down into this container. And you can see it's just water. Water, gravity, suction, centrifugal force, whatever fancy science terms you want to use, and it all came together in a, as you see, there's the water in there, so it's leveled out. You see the level of the water outside is equal to the level of the water inside, so it equilibrium. So that's why it's not overflowing, even though there's still water in here to pour out, because it's all leveled out, it doesn't, which is important. Aha, I'm learning something, right? Physics. Equilibrium. That's a word, look it up. Equilibrium. So the fact that the water in this container is at the same level as the one outside, right? Create equilibrium. So now it's not overflowing, even though there's still water here to drain out, and there's a hole where water should be draining out, but because of the equilibrium, right? Equilibrium. So water's leveled out. And all you have to do is take the water that's in here, right? Put it back up here, and then have it come back down. I originally had a piece of tape, which is right there, the electrical tape that I used to cover the hole at the bottom of this when I filled it up with the water from that cup. And then I used the butter knife to spin it. If you rewind this video to the beginning, you'll see that there was spinning. Now, ideally, what I want is the spinning to go all the way down to the funnel, right to the hole, and to be a long, whirlpool. But the best I was able to do is get the whirlpool up here. So the whirlpool is up here, but the hole is down here. So I gotta figure out, like, I might have to make this shorter. Maybe this container needs to be bigger, and then this funnel needs to be shorter, so I can get more spin. Because the idea is I want the hole to be spinning. I just want it to be bigger. That's what she said, right? I just want it to be a bigger whirlpool than the little one I got, because you get more force out of it. So like I said, I don't know all the ratios yet. I'm still experimenting, but this is the start of whirlpool technology. Ancient whirlpool technology, to be exact, because the inspiration for this concept is from ancient times, or what I believe ancient humans did. They created whirlpool technology and used it to do cool shit, which eventually I'll show. The idea of this was to eventually have it where I have like a drill, spinning, because of the whirlpool, right? And then put a piece of rock on top of it or something, and then have it drill. And be like, oh, look, see, you can use spinning water, a whirlpool, to drill into rock. As an example. I did it. I finally got it. Yes, I figured it out. I finally got it. Awesome. Oh, yes. Starting losing momentum, but let's do like a stir it up a little bit. A little bit more. Try to get that effect. You see how it's going down now? Come on, keep going. You're almost there. See, there's a different whirlpool in there. Right in the middle, going down that hole.